Welcome to my class of computer graphics. Today we will learn about polygon filling. What is a polygon? Before understanding any algorithm, we need to know the definition of a polygon. A closed figure represented by a collection of more than two line segments connected end to end is known as polygon. The line segments are known as edges of the polygon and make up the polygon boundary. End point of these edges are known as vertex of the polygon. So, what are the vertex? The end points are known as the vertex of the polygon. What are the types of polygon? Simple convex, simple concave, non-simple, and self-intersecting. Self-intersecting means when the polygon cuts itself, then it is called self-intersecting. That means the two lines of the polygon, of the same polygon, intersect itself. Then that is called self-intersecting. Let us see the difference between convex polygon and concave polygon. All points on the line segment connecting two points of the polygon are also inside the polygon. That is convex polygon. All points on the line segment connecting two points of the polygon are not inside the polygon. That is concave polygon. In convex polygon, all interior angles lesser than 180 degree. And in concave polygon, at least one interior angle is greater than 180 degree. In convex polygon, all of its lines curve outside. In concave polygon, at least one line curve is inside. As we can see in the diagram of concave polygon, that at least there is one curve that is present inside. One thing that we might note about a convex shape is that no matter where you draw a line that passes through the shape, it will always pass through only two of the lines or polygons making up the shape. Whereas in case of concave polygon, if we try the same thing with a concave shape, it can pass through more than two of the lines. Now, let us study the inside-outside test. What is inside-outside? See, here the lines are discriminated at inside and outside, even odd test and winding number test. Similarly, in even or odd test, it is also known as crossing number methods. In this method, a line segment is constructed that crosses the given polygon and then count the number of times a line crosses the polygon boundary. If the crossing number is odd, then the line is inside the polygon, else outside. Special case, when point of intersection is the vertex. Now, there are two cases. One is case A, edges are monotonically increasing or decreasing, and case B, edges reverse direction at end point. In case A, we should consider this as only one edge intersection. In case B, we should consider this as two edge intersections. In the diagram it is clear, one is case A and another is case B. Here in case A we can see that edges are monotonically increasing, and in case B edges are in reverse direction at the end point. So these are the special cases. Now let us look at the different algorithms for polygon filling. What are the different algorithms? Filling a polygon is the process of coloring every pixel that comes inside the polygon region. What are the techniques? Different techniques are boundary fill method, flood fill method, and scanline fill method. These are the different types of polygon filling algorithm. If we look at boundary fill method is also known as seed fill method. You can see in the diagram that there is a seed, and the seed fill method, we draw polygon boundaries and fill up the seed point. A seed point, that is an arbitrary interior point, is taken as the initial or the starting point. We test the neighboring pixels to determine whether they correspond to the boundary pixels. If not, paint them with the fill color and test their neighboring pixels, and we store neighbors in stack. And we continue this process until all pixels have been tested. Now in this, generally two methods are given in boundary fill algorithm. This algorithm is also known as area filling algorithm. This is used where we have to do an interactive painting in computer graphics, where interior points are easily selected. If we have a specified boundary in a single color, then the fill algorithm proceeds pixel by pixel until the boundary color is encountered. This method is called boundary fill algorithm. In this diagram, we can see that there are two variations. One is 4 connected and another is 8 connected. In 4 connected, there is a selection of the interior pixel which is inside the boundary. Look, it is in the center and is represented by different color. Then in reference to that pixel, the adjacent pixel will be filled up, that is top, bottom, and in left-right fashion. In case of 8 connected, this is the best way of filling the color correctly in the interior of the area defined. This is used to fill in more complex figures. In this, 4 diagonal pixels are also included with a reference interior pixel, and it includes top, bottom, and left-right pixels. Now let me explain the boundary fill algorithm. Boundary fill algorithm is an area filling algorithm that is used where we have to do an interactive painting in computer graphics, where interior points are easily selected. If we have a specified boundary in a single color, then the fill algorithm proceeds pixel by pixel until the boundary color is encountered. This method is called boundary fill algorithm and is used frequently in computer graphics to fill a desired color inside a closed polygon having the same boundary color for all of its sides. Generally, there are two methods. Two methods are 4 connected. In this, firstly, there is a selection of the interior pixel which is inside the boundary, then in reference to that pixel, the adjacent pixel will be filled up, that is top bottom and in left right manner. Now if we talk about 8 connected, 8 connected is the best way of filling the color correctly in the interior of the area defined. This is used to fill in more complex figures. In this, 4 diagonal pixels are also included with a reference interior pixel, including top, bottom and left, right pixel. Now, we will look into the algorithm part, how the algorithm is implemented. The most approached implementation of the algorithm is a stack-based recursive function. So this is the most common way of implementation. What are the different steps? Let us look into the steps one by one. Step 1 is take the position of the straight point and the boundary color. So we take the position of the straight point and boundary color. Now we will look into the step 2. Step 2 is decide whether you want to go in. Here we are looking for 4 connected. So decide whether you want to go in 4 directions. 4 directions. What are the 4 directions? North, south, west, east. These are the 4 directions, or 8 directions. North, south, west, east, northwest, northeast, southwest, southeast. So these are the 8 directions. Now what is third step? These are the 4 directions. Now we look into the third step. What is the third step? Third step is choose a fill color. Choose a fill color. Why we will choose a fill color? A color will be chosen for filling up the polygon. Now, next point is travel in those directions. Now we will travel in those directions. And the 5th point is, if the pixel is not the fill color or boundary color. That means suppose it is of different, it is not fill color or boundary color, then replace it with the fill color. We will replace it with the fill color. Now there is a loop. Repeat step 4 and step 5 until all the pixels are filled with appropriate colors, within the boundaries. So this is the algorithm. Here the loop will work for step 4 and for step 5. Now there is a problem with boundary fill algorithm. What is the problem? It may not fill regions correctly if same interior pixels are also displayed in fill color. In 4 connected, there is a problem. Sometimes it doesn't fill the corner pixel as it checks only the adjacent position of the given pixel. The boundary color should be same for all the edges of the polygon. And also the starting point should be within the polygon. Now there is another algorithm which is known as flood fill algorithm. Let me write. Flood fill algorithm. This is another type of algorithm. By this algorithm, we can recolor an area. We can recolor an area that is not defined within a single color boundary. In this, we can paint such areas by replacing a color instead of searching for a boundary color value. The whole approach is termed as flood fill algorithm, and this procedure can also be used to reduce the storage requirement of the stack by filling pixel scans. Now let us look into the algorithm. Let us look into the steps of the algorithm. Here flood fill, X, Y fill color, old color and integer. These are the value. Fill color decide the value that will be used for filling up the polygon. Now, let us write the algorithm. Begin if get pixel, in bracket you will write x comma y is equal to old color, then begin. Again inside that we will write begin. That means there is a if condition. Then there are steps that if we will compare first that if get pixel x comma y old color, then wait, then we will use set pixel function. Set pixel x comma y comma fill color. Flood fill. Here all the 4 values will be colored. Connected 4 values, adjoining 4 values will be colored. Flood fill x plus 1 comma y comma fill color x plus 1 fill color. Then we will again write flood fill x minus 1 comma y comma fill color. Then we will again use the flood fill algorithm. Flood fill x comma y plus 1 comma fill color. This is the algorithm. Then we again write flood fill x comma y minus 1 comma fill color, and then we will end. That means here the function, the 4 adjoining coordinates are filled up. So these are the mainly used 2 polygon filling algorithms. After attending this class, all of you should be able to solve the boundary fill algorithms problem. That means if suppose any polygon filling algorithm is given, then or polygon filling problem is given, then you should be able to solve the numerical questions based on this algorithm. This is also known as scanline polygon filling algorithm. Okay, so these are the different types of algorithms. Thank you for watching.